Hello. Thanks for coming. I work at Azavea, as was mentioned, and I want to talk a little bit about some work we did to bring static maps. It's kind of related to some election data we've been working with this summer, but I want to talk about lessons we learned from how those maps were distributed and workflows we used to produce them in a scalable way, which here means different than zooming in or out. So the challenge is we often have clients or someone we want to work with who might be a local advocacy group. They could be a local newspaper. The idea is that they have an audience who's has a local interest in a place, and we often have the data sets that cover their areas. So think about, in this example, we might have a nationwide data set for states, and we want to produce a set of infographics or tell some story related to that data. But these smaller groups don't have the capacity on staff to produce the graphics or design the maps like you would with a larger publication. So that's where we come in. And there's some, so that goes several ways. As an example, these are congressional district boundaries in Pennsylvania created for a group that's interested in the redistricting process. This is an interactive map one of our colleagues made for that group. It's very well designed. It shows it's a time series of how these district boundaries change over time. The advocacy group put it on their website, and that's kind of where they distributed it. And then journalists and their volunteers all went there to use it. We did a slightly related blog post. We did some research about the efficiency gap and some redistricting metrics and took that data and created state-by-state infographics and shared them as a gallery of images. This not being interactive, but just static production of images for each state. Both these got picked up by a state newspaper in Pennsylvania, and they were included in the article. This was a journalist who knew he was on a deadline and he wanted to publish something quickly, so he found local experts and started including some of these graphics in the publication. But kind of an interesting thing happened cartographically when these graphics were brought from where we published them to the actual platform that had a real audience, which was the newspaper. The static image, the gallery of static images, kind of just turned into a single static image for the location that the journalist was interested in. So a lot of the design decisions we made early on were left unchanged. For this infographic, we did stuff like we looked at what's the recommended dimensions for social media sharing. Is the text going to be legible? Is there a bit of a narration to it? And does it all lives kind of on its own within itself. When the journalist picked up those interactive maps, what they did was they just took a screenshot, which happens all the time with these interactive maps. So things were dropped from the cartographic design, including the title, the framing of each map, some of the frames from the animation were even left out. The screenshot was kind of rough, and there's some borders that were kind of included in some and not others. So these are small details, but from a cartographic perspective, it's something you might consider when we're producing stuff that we know is going to be consumed locally by people who don't have the same training in graphic design, et cetera. So a lot of those original design decisions, although it was a great application when you had control over how it was distributed on the web, when you did the custom integration with the website of the local advocacy group, that worked well on the left there, but it lost some value, while still probably effective. It lost some value when it got distributed to a wider audience, which is ultimately what we want for these maps, is to have more eyes on them and to help them have a larger impact. So this is a bit of a distribution problem. What decisions can we make to design maps so that when they're shared around the internet or printed out and shared or dropped in a presentation in some community meeting, how will they still remain as effective as possible? And the biggest problem is that people are going to screenshot your interactive map and then drop it in their blog, share it on the internet. It's going to happen every time, unless you are publishing on a large platform already. If you're publishing to a national newspaper or something like that, you have control over that. But ultimately, as more eyes get on it, it's going to sort of lose quality. And it's just going to end up being an image that someone's tweeting out or sharing. So the answer is we can make some design decisions early on to make sure that these maps are shared effectively no matter what platform they're on and no matter who's doing it and who's sharing them around, so that people don't have to have a ton of training behind it. And that means that they're going to pretty much be static. They're going to be image files or PDFs, or they're going to be simple, and they can't be messed up when someone wants to share it with their friends or their community. And the problem then becomes, if we have, the reason we made it interactive in the first place was because you wanted to show every congressional district in Pennsylvania, or you wanted to show every state in the country, and the idea was the user comes to your website, zooms in on their home state or searches for their address. You want to show a lot of places, but if you know that that's not going to work as well when it's shared later on a larger platform, maybe what we need is a lot of static maps. And so this is about scalable static maps and how we can scale up our production of those maps so that we can achieve great design. Because you don't want to, if you're making a graphic that's supposed to show election results in every of 50 states, that becomes challenging if you decide you want a static image for each of those. You might end up investing a lot of time and energy, but we've explored workflows that could get around that. So conventionally, you would have a desktop GIS, you would export that into like a vector Illustrator software, you would design your infographic, you might do it just one infographic, you might have a series like a map atlas, but anyone who's done that before know that that can turn into a lot of work, although it does give you great control over the end product. But if you want something like 50 infographics, one for each state, and you want to be able to make it in just really short time frame because you're working with a journalist on a deadline, or because you want to be able to go back later and tweak the color or change the text or something, and you don't want to have to make that change to every single Adobe Illustrator file and then re-export everything and try and organize that and keep track of it all, there's another way. So what we've explored is using some web technologies and web tools for producing static images in a way that's quick and gives us all the control that we want as cartographers, and you can get to a pretty good product that's kind of comparable to what you could produce in Illustrator. So the technologies specifically that we're using are D3.js, Canvas, and Node.js. So Node is a scripting language that's it's a JavaScript scripting language, so it's kind of like a Python, and you can run it. You can write a script and have the programming execute. And the reason we're using Node is because there's a lot of great visual tools that are already written in JavaScript, specifically D3. D3 is data-driven documents. It's used to already create a lot of web maps. There's great tools for data visualization. You can map stuff, you can make bar charts, you can put them together. And then we're using Node Canvas, which is a kind of virtual image file that you can paint shapes on. You can use directly with D3 to draw maps and boundaries and graphics and text, and then save that out to an actual image. So the idea is that you script it, and then you might have a data set with 100 different locations, and you would iterate in like a for loop or something like that, and create a map for each of those, doing the same, using the D3 to create the same graphics on each one, but framed based on the location that you're interested in. So this is kind of that workflow. Say you're working with a county or a city, and you want 1,000 individual maps of each parcel in the city because they know that they're going to mail something out to every household, or everyone uses like PNG files, and it's just the way it's going to be. And the city doesn't want someone coming to their kind of complicated web application and navigating through there to find their house. So you might have a single geographic data file, that's parcels.geojson here, that has the attribute information you need on it, and you would send it through this processing script, which is written in the Node JavaScript, and uses things like D3 and is kind of creating this canvas, this image, and then it writes it out to your first map and then your second, your third, scaling up. Those are the scalable static maps as output. So there's some cool tricks involved here that really make this possible. This is what it looks like when you have a virtual canvas and you've drawn stuff on it and you want to write it out to a PNG file. This is something that gets executed by Node, and you write it to whatever naming convention you want. One thing that really made this possible was D3's support for different projections and for framing the map. Because you don't want to, some of the hardest thing about creating a map atlas is that you have to set up the individual framing on each map. So this bit of code here, and there's a link to that online, will take a GeoJSON feature, take a boundary, a geographic boundary, and automatically, in this case it's using a Albers projection, rotate to it, frame it, set up the parallels, all the parameters that you would give to a standard projection, and then that can serve as the basis for your map graphic. Because we're writing this in a procedural programming language, we can handle all sorts of edge cases in our designs. So each time you're writing an image, each time you're creating a static map, you can check something about the data, maybe a value, and say if it's really big, we're going to give it a special color, or we're going to highlight it, or we're going to change the descriptive text that we write underneath it. All these edge cases and conditional statements become super valuable. And because we're doing all of our designing in the code, you can start using things like Git for version management, and you can iterate quickly. So Git is something that will track your progress. So it's like the undo button in Illustrator, but lets you go back further and manages the code for you. So like this animation here shows our earliest, right there, earliest designs, and then as we iterate through it, you can see the progression. Now, if we had gotten to an early design and we decided to scale it up right from the beginning, and maybe I'm working in Illustrator and I have 50 individual files and I'm making all these changes, then I meet with someone on my design team and he says, well, it would be better like this. I can go ahead and make those changes. I only have to do it once and then reproduce all those images in about 3 seconds. And we can get to a better design in the end. And finally, because they're just static images, the distribution potential is limitless. You've kind of escaped the iframe. If you have an interactive map and you want to share it on someone else's website, you have to call them up and coordinate and talk to the developers. How are you going to get this iframe on the site? What's it going to look like? Is it going to be responsive on mobile? But if you have a PNG file, that can live anywhere. You can put it on the web, share it on social media, send it to someone in text, print it out. Someone can drop it in their presentation. It's going to look fine. PDFs, you can even fax it. So the idea is that it's kind of limitless potential then. So thank you.